All right, everybody, welcome back. This week we are going to be covering K-means clustering. So let's begin our presentation on the next slide. So K-means clustering is a type of unsupervised machine learning algorithm. Okay, what does that mean? Well, it means that you and I, the machine learning engineers, we do not tell the computer what are the features and what is the dependent variable. Instead, the computer decides what is the relationship among all the features. Okay, so in a way, the computer will say, okay, I don't need your supervision. You don't need to supervise me anymore. I'll supervise myself. So that's the reason why it's called unsupervised learning, because we're not telling the computer, we're not supervising the computer. Instead of us telling the computer, hey, these are the features, this is the dependent variable. No, the computer decides what is the relationship among all the features. And that's why it's called unsupervised. And it's a type of clustering machine learning algorithm. Okay? So let's continue. So let's continue with K-means clustering. So, and like I said, K-means clustering is when the algorithm, we do not tell the computer, hey, these are the features. Okay, we do not tell the computer, and this is dependent variable. No, we don't do that. Instead, what we tell the computer, hey, these are all the variables. Okay, here are all the features. You decide how all of these features are related to each other. And then the computer says, okay, they're going to be related by common characteristics. So what are the common characteristics of all these features? And based on the common characteristic, it's going to create clusters. Okay, it's going to create clusters based on how are they related to each other. For instance, in this specific case, it created three clusters. Cluster number one, cluster number two, cluster number three. And the first cluster is made of affluent and middle age. The second cluster is made of young, educated, and middle income. And the third cluster is made of young and low income. So the computer determined that the relationship between all the features is that middle age is related to affluent. Highly educated young are related to middle income. Young are related to low income. That's what the computer found. Okay, and it did that on its own. We didn't need to tell it, hey, these are the features, and this is the dependent variable. It did it on its own. Okay. So the machine learning algorithm, what it does, it tries to maximize the distance between clusters. Okay. So you got two clusters. It's going to try to maximize the distance between the cluster. And at the same time, it's going to try to minimize the distance within the cluster. Okay? So all the points within the cluster, it's going to be the distance between them is going to be minimized. Between cluster, the distance is going to be maximized. Okay? So let's continue. So before we continue, let me show you how we calculate the distance between 2 points, right? So we have a point here, we have 1 point here, okay? Right here we got 1 point, we got another point. And we want to know the distance between these 2 points, okay? And the way we calculate the distance between these 2 points is by using the Euclidean formula. So this is the Euclidean formula. And we're going to use this formula to calculate the distance between 2 points. And it's pretty basic mathematics, okay? So we got 1 point here, we got another point here, right? So let's do the calculation. So very simple. We take this point here, 54, 50, okay? 190 here, 200 here, and then we solve, right? We subtract, and then we add, and we get this one, 10.77. So the distance between these 2 points is 10.77. And you're probably wondering, so why do we need to know the distance? Well, because we are going to be calculating the distance between all the points. Okay, remember, let's go back to here. We're going to be calculating the distance between all the points, okay? The points and the clusters. That's the reason why we need to know how to calculate the distance. So let me show you. So I'm going to take you step by step on how the machine learning algorithm does it, okay? How the machine learning algorithm create these clusters, okay? And how does it maximize the distance between cluster while minimizing the distance within the cluster. So I'm going to take you step by step on how to do that, okay? So let's begin. So I want you to pay close attention to this point, okay? To centroid number 2. Pay close attention to that one because that's the one we're going to be using, so that way you can generalize to all the other points, okay? Keep an eye on that one. So the first step is to initialize. So you need to initialize how many, in other words, we need to decide how many centroids or how many clusters do we want. In this specific case, we decide to use 3 clusters, okay? 1, 2, 3. However, there are machine learning algorithms that decide for you the optimal number of clusters, okay? So there are other sophisticated machine learning algorithms that decide, okay, the maximum number of clusters is this. But for the learning purposes, we're going to decide three clusters, 3 centroids. And then the centroids are randomly placed in the 2D plane, okay? Randomly placed. And again, there's actually another machine learning algorithm that actually decides where to locate the centroid for optimal placement. But for now, it is randomly placed. All the centroids are randomly placed, okay? So we got centroid number 1, centroid number 2, centroid number 3. Randomly placed, and we told the computer we wanted 3, okay? 3 groups or 3 clusters. Now, here's what we do. We calculate the distance, okay, for every single point, okay? We could calculate the distance for every single point from all the centroid, okay? We're trying to say, okay, so let me take every single point and calculate the distance from that point to every single centroid. Centroid number 1, centroid number 2, centroid number 3. And then once we calculate the distance, what do? We assign the centroids that are closest to the, we assign the points, okay, that are closest to the nearest centroid. So that means that these 3 points are closest to the centroid. So we assign it to the centroid. These 2 points are closest to the centroid. So we assign it to the centroid and so forth, okay? So that's how we do, right? So we assign every single data point that is closest to the nearest centroid to the centroid, okay? Then what do we do next? Now we have, that's what we did. So we assign each point to the closest centroid, right? So these points are assigned to this one. These 2 points are assigned to this one. And all of these points are assigned to this one, okay? Then what do? Now we need to move the centroid. Okay, so remember, centroid number 1 was here, right? Centroid number 2 was here. Okay, centroid number 3 was moved here. So now we need to move the centroid, okay? Because we cannot move the points, right? The data point, we cannot move the data point. So, but we're gonna move the centroid. And here how we move the centroids, okay? So let's focus on this one, okay? Centroid number 2. So we know that centroid number 2 was here, but it was moved here. How do we determine to move it there? Well, we take the average, okay? So you got this point, and we got this point, right? Now we actually add those 2 points and we take the average. So for example, you take this one, you add it to this one, right? And then you divide it by 2. You take this one, add it to this one, and divide it by 2. And when you do that, I'm sorry, I apologize, I made a mistake. Actually, let me correct, I made a mistake here. Is you take this value, add it to this value, divided by 2. Take this value, add it to this value, divided by 2. And once you do that, you get 7.6, 3.7, okay? So this is the new location of the centroid, okay? And we do the same for this one, we do the same for this one, okay? And once we move the centroid, guess what? We repeat the same process again. Remember, now we actually calculate the distance for every single data point and find the nearest centroid and assign it to that centroid. We do that repeatedly until everything has been separated thoroughly. You can use this for marketing, right? You're trying to find patterns in your customers, okay? You can do this if you want to recommend books, right? And let me give you an example. Let me give you an example about that. Let's say customer A, actually, book A, customers who buy book A, they also buy book B, okay? And customers who buy book C buy book D. So that means that you can actually create a cluster. Okay? This would be a clusters. Why? Because we know that customers who buy book A normally buy book B. And we know that customers who buy book C normally buy book D. So that means that if a customer, right, let's say you are a brand new customer and you buy book A, then the machine learning algorithm is gonna tell you, hey, I'm gonna recommend book B. Why does it recommend book B to you even though you are a new customer? It's because in the past, customers who buy book A normally buy book B. So it's gonna recommend book B to you. And that's how recommendation algorithm works. That's how Amazon works. That's how they're able to recommend what to buy next. That's how Netflix works. That's how they're able to recommend which movie to watch. They use clustering, by the way. Of course, banking, fraud detection, credit use, okay, insurance, fraud detection as well. Publication, you can auto-categorize the news based on the content. You can recommend news articles, just like I said. Medicine, you can characterize patient behavior. Biology, you can cluster generate markers to identify family ties. So it has a lot of applications. Mm-hmm. Lots of applications. Okay, so let's continue with the presentation. But now let's look at the code. And here, the first block of code, just like we've seen before, right? The first thing that you do is to actually import the libraries that you are going to be using to create a machine learning algorithm. And that's what we do here, okay? Then the next block of code, just like the other block of codes that we seen before, we import the data set that we are going to be using it, and then we actually want to see the first 5 rows of the data set. And that's what it does, right? You're the first 5 rows. And then we move on. we want to do some basic data checks, right? We're missing for missing values. Okay, we're looking for missing value. Are there any missing values? And we see, yeah, we got a lot of missing values. So what do we do with these missing values? Well, we're still gonna do something. We're gonna start cleaning up all these missing values. Okay. So that's actually before they were fixed and after they were fixed. So after they were fixed, there were no missing value. Before, they were missing about 150 missing values. Okay? But after, all the missing values were deleted. Let's continue. Now, this block of code, what it does is when it selects the features, right? But remember, this is an unsupervised machine learning algorithm, which means that we do not tell the computer what is the dependent variable, okay? We just let it decide what is the relationship among all the features, okay? And it decides, okay, so here's the relationship among all the features, okay? Then we look at the first 5 rows of all the features that we selected, okay? And here are the first 5 rows of all the features we selected. Then we create a histogram and box plot. Well, we create a histogram, okay? Because we're looking for, remember, one of the reasons we use histogram is because we're looking for outliers. Are there any outliers, okay, that can really mess up your machine learning algorithm? And the same for box plot. You see, oh, there's a ton of outliers here. There's something weird going on here. Like this one and this one, yeah, it's weird. It seems there's a lot of high income here, okay? And then we do some heat map, okay? Give me a second. We do heat map. And again, remember that the features are supposed to be, hold on, give me a second, are supposed to be independent. Remember, the features are supposed to be independent from each other, meaning that the features cannot be measuring the same thing. They have to be measuring different things. And one of the examples I always give is education and IQ. In that education and IQ both measure the same thing. In that people who have high IQ are most likely going to have a higher education. And people who have a higher education are most likely going to have a high IQ. So these two variables are going to be measuring the same thing. So if you build a machine learning model and you have these two variables as features, you're going to have to decide which variable you're going to keep, because you cannot keep both. All features gotta be independent from each other. They cannot be measuring the same thing. So here's what you're looking for. You're looking at any relationship. Is there any correlation between the feature? If there is, I'm gonna have to decide which feature to keep, but not keep both. And here we're looking for scatter plot. We're looking for outliers. Anything that is like, look at this one, income here. That's a big outlier. There are two outliers here because most income are here, but yet we have this income here. So we're looking for outliers, okay, for scatter plot. Let's continue. This block of code, what it does, it splits the data set. Remember, you have to take the original data set, you gotta split it into two. One is gonna be used for training, and the other one is gonna be used for evaluation, okay? And this is splitting the data, 70-30. That means that 70% of the data will be used for training and 30% is going to be used for evaluation, right? 70-30, yes. So 70% for training and 30% for evaluation, right? Then we move on. We do some standard scaling. Okay, we remember sometimes we scale the data so that way all the variable, all the feature have the same impact as the other ones. Then we move on. We do elbow method to decide what is the optimal number of K. Remember K? K is the number of centroid that we create. At the beginning, we probably chose 3K randomly. But now, if you use the elbow method, it's going to tell you what is the optimal number of K, or the optimal number of centroids, or the optimal number of clusters. So here's the K. So it's actually looking at the inertia, okay? And it seems like if you got two centroids, you see that the difference between 2 and 4 is very dramatic. There's a big fall. There's a big change, okay? But then after 4, the change kind of drops off, okay? Kind of drops off. So it means that the optimal number of centroid is probably going to be 3 or 4. Probably 4, okay? So because the change here between 2 and 4 is very dramatic, but then it actually kind of falls off. So probably the optimal number of centroid is not 3, but it's actually 4, okay? 4 centroids. Let's move on. So we train the model, okay? So we do some training, okay? And here the optimal K. We still keep it at 3, but it seems like the optimal number is actually 4. But for this training purposes, we're going to keep it at 3, but based on the elbow here, it's probably 4, but we're going to keep it at 3. But this one actually says 4. But this is just for educational purposes, okay? You're going to create 4 clusters of 3 central or 3 clusters. Then we do some training. Then we calculate. So here we calculate the silhouette score. Okay, what it does. Okay, so we look at this score. Okay, so here's what we're trying to do here. So what does this mean? Okay, let me tell you what this means. So what this means is that if you look at the every single data point, right? Let's go back. Let me show you something. So let me show you something. So we have 3 centroid here. We got 3 clusters, right? What it does, the silhouette score, it tries to measure the distance between all the points in one cluster, and measure the distance from it's within the cluster to other clusters, okay? And try to see how close am I to the other cluster. So it's trying to determine, does this point here, does that belong to the cluster number 1? Does this point really belong to cluster number 1? If it does belong, how close is it to the other cluster? So what it's trying to determine, does every single data point that is assigned to a cluster, does it really belong to that cluster? Or maybe it belongs to another cluster. So it's trying to see if the clustering is actually correct, okay? So the score, so here it is. So let me interpret the score for you. If it is 1 or more than 1, it's actually very clustered. It means that it is really, really clustered, okay? They're really separated. If it's 0, it means that there's some overlapping going on. If it's negative, it means that it's probably some type of misclassification. And this one is not bad, it's not good, it's like kind of so-so. And I think you can see there's some overlapping. If you see that, there's some overlapping going on. If this score had been 1 or greater, this would have been really separated. The cluster would have been really separated. And you can see that 0.28, it shows that it is closer to 0, meaning there's some overlapping going on. And there is some overlapping going on. You can see it. So then we create a visualization, cluster visualization. And here it is. We got our clusters here. We got cluster number 0, purple, cluster number 1. That looks like blue teal. Cluster number 2, yellow. And here are the clusters. And that's how you read this K-means machine learning algorithm code. I hope you learned something. I wish you all the very best.